at a company called Flow. And this talk really is about how we build software at Flow, or how we find our flow through API-driven development. And so Flow is essentially a B2B software company where we provide a REST API to help e-commerce retailers sell globally. And what this specifically means is that we enable all of these companies to be able to do all of the specific things they need via API calls to fulfill stuff from here going to customers around the world. And so, obviously this one is a technology talk, so I'm going to talk a little bit about what we do. And so for just a little bit of background, we run a microservices infrastructure built on the back end in Scala and Play. And there are event streams all behind that. The front end is React Node.js. And all of our infrastructure runs on Docker containers hosted in AWS. And there's a little bit small thing here about the word flow. Where did that come from? And basically, it really means like you're in the zone. So how can retailers get in the zone of selling internationally? And for our API-driven development, what does this mean so that developers can be like more productive and really get into the zone, really build a product without managing a lot of the cruft that typically goes along with it. And so a microservice architecture, if you run a microservice architecture in your organization, you probably see some of these things. So there's a lot of common boilerplate across all of the various services. Like different teams, different people tend to do different things differently. At a previous company I worked with, a lot of us from Flow had the background of being from a flash sale retailer guild group. We ran a microservice architecture. We were truly like one of the first places that went from a monolith to a microservice. And one of the hard learnings over there are precisely this. It's hard. It's very difficult to maintain. A lot of teams will do things differently. Like someone will write some code in one service, another team takes over of that service. They have no idea what's going on, and therefore they'll just end up rewriting it to do the exact same thing. And documentation is hard. It's hard enough already just to write it. It's even harder to keep it up to date. And meaningful alerting and reporting around common metrics around all of the services is very difficult also. Just because everything is a little bit different. So developers get stuck doing all of these things rather than building the actual stuff to do the stuff that they were paid for to solve the problems of the retailers in our case, or to build whatever it is they were signing up to build. So here's at a high level what our architecture looks like. Over here in the lower part here, those are some of our microservices. There are about 30, 35 of them now in production. This one just simplifies it a little bit. So, each one of them is a microservice backed by what typically would be a Postgres database, and a lot of them will emit events into these event streams, which we have in AWS Kinesis right now. And so, an example of this is when typically what we ask from our clients is that they'd send us their catalog first. And so they send us their catalog with their products. We call them items into our catalog. It goes through our catalog service. It emits events, and any of these other things that need to act on them will listen to the events as they happen, or when they are in the Kinesis stream. This proxy layer over here serves as a common layer that our clients integrate with. So whether that's our own Flow console, which we develop internally, or the SDKs that our customers use, it's all the same. They all go through the same proxy layer. And so, API models and resources, just a little bit here. All of our stuff is documented on API.me. That's a personal pet project of our co-founder and CTO, Mike Brisick. And all of the stuff that we work with on the back end is Scala in play, as I mentioned. We have a linter to enforce consistency across the APIs. Because if one person will build something differently, some other person will work on a different microservice. We want to make it look like it's actually just one service, so the clients can consistently go onto multiple models or resources. They should all look the same. And we, to produce that proxy thing, there's essentially a builder that gets all of those definitions, merges them together, and it's basically served from that part over here, that proxy. They hit that, and it actually proxies to one of these other microservices. And so this talk really will just walk you through what we actually do here. So here's a definition of a catalog item. This is how we document the model. Here are all of the fields or the descriptions or types, and here are all of the resources or the endpoints. I don't know if you guys can see this, but basically, there's like you can put an item, you can post an item, you can. There are multiple get endpoints that do slightly different things, and a lot of this structure is consistent across the different models in our API. And as I said earlier, when we build a single API definition from multiple ones and multiple services, our proxy layer now can be smart enough in enforcing that. And so when our clients integrate with us, they may see things like validation errors around like missing fields over here. Hey, the form requires all of these fields. You only passed in name, error, and that. And so typically, what might happen is that it's very difficult to keep this up to date. But this one is actually super up to date, and it's exactly what we have on the back end. And so the documentation is also auto-generated, so you don't get into this phase where a lot of the things are, it's very difficult to write documentation. We wanted to make it a natural part of our workflow. So the way this is generated over here just comes from whatever you put over here and the descriptions over here. And so everything stays consistent with what's in the canonical model as it is right now versus what's in the documentation site. And so this one relieves a little bit of frustration from our clients where, I've integrated with a bunch of APIs before where you go to their documentation site, you try something on curl, it doesn't exactly work the same way they said it would. And so, we wanted to solve that. And this was our way of making sure the documentation is essentially up to date. It has to be generated. It doesn't, and it's not an impediment towards developer productivity. And so with the auto generation thing, we can also do stuff like generate a Ruby SDK. Which our early clients used. A lot of our early clients were smaller companies that used Ruby on Rails. So this was something really essential that we got. So anytime our API updates, the gem can automatically be generated, and then you have a very clear distinction of what's available, what changed, and how do you communicate with Flow right now. And so another one is our Node SDK. Our front-end team actually uses this auto-generated Node SDK for our front-end. As I was talking earlier about what the stack is, our front-end uses the exact same auto-generated code so that it can consistently talk with the back-end API layer. And so I was talking a little bit about events before. And so the event models are essentially a JSON payload that we put into Kinesis, and they're also defined in API doc. We write them like this. They're also auto-generated. And then what can we end up doing with them? Not sure if you guys can see this, but essentially this one is a processor that we have in a consuming service. So this service, say, is interested whenever a new catalog item is uploaded by one of our clients or the data has changed. The event will drop into Kinesis, and something that's interested can easily consume it. And I think the code is pretty straightforward, and all of the services do look like that. And a lot of the tests also can be auto-generated. A lot of the things that we worked on really just look like that. It's just making sure that the event is able to flow through from end to end. You put in a fake event into the mock queue, it's able to get processed, and the effect of that is that it's in the database in the end. So a lot of this is pretty standard. And so we also generate a lot of the things that talk to the database now. So here's another thing where we use auto generation using the same API framework, where we're able to say, okay, here are the columns in my items table, and here's some meta information about what I want to generate. And then I could generates a Postgres schema, generates a Scala DAOs. So a lot of this we found at the start, we were just copying and pasting everything, so it was just better to come up with a generator to do that, and everything looks consistent across multiple services. So I have a little bit of time, but so far, essentially, most services tend to be structured the same way. We think it's it's a pragmatic approach, especially since we're an early stage Series A startup. We're supposed to be scrappy. We're supposed to be building a product, going after customers, and so you want the development process to be as predictable as possible, but still not hinder developer creativity when they actually are building the core meat of the product. So someone's actually working on currency conversions or doing things like tracking a package. A lot of that you can concentrate on just doing that and none of the boilerplate around it. And so this made it easier for people to move around teams. A lot of the services sort of look the same. It's made it easier for troubleshooting. I don't know if any one of you heard of a truck number, sometimes called the bus number, but basically it's like the number of people needed to be hit by a bus before your company is screwed. So I think this is actually it should actually be higher truck number because more people can be hit by a bus before our company is screwed. And the generators also improve over time. We add new stuff to it. We think things like having the generator actually add an index will make things easier, or generating a lot of the helper classes in our Scala DAOs will make things easier. So you can improve those over time, and the rollout is super easy because everything just goes through the same thing. I guess almost everything is consistent. I think it's also helped us eat our own dog food. It's not something that, say, here we provide this API to customers, but in the back end, what we're really doing is, doing all of this other stuff that that they don't have access to. We don't really like that, so we prefer to see like if it's something that that works for us and we love internally, our clients will probably love it. And we've found that a lot of the developers are generally happier also in the end because they're able to concentrate on the meat of what they want to do, which is actually solve the problem rather than all this craft around how do you set something up, how do you set a new service up, how do you set a queue, all of those things. And so I know I'm out of time, so I'll open the field to questions. Sure.
You got to build this from the ground up in Microservices Architecture?
Yes, that's correct.
Do you ever wish you got to work in monoliths instead?
Do you
ever miss monoliths?
There are times when it's a little bit of a loaded question. Sometimes I feel that a monolith would have been easier for certain things, but when you get to things like especially with issues of scaling certain services, like some services need dedicated things that other services don't. Then we're pretty happy we chose to go the microservices route, and so individual developers can also feel that they are more empowered. They really own something in their specific area that more or less shouldn't really bring down the entire infrastructure, which is what microservices was for. You create this break out this well-defined module within the larger system, and then someone would be able to really own that. And I think for the senior developers on the team, that was really empowering because they're not trying to figure out like, well, if I work on this, will it break someone else's code? And so we're able to iterate very quickly with what we have. I think a lot of the things that people generally say when they miss a monolith, I think what they really mean is that, well, I don't have to rewrite a lot of the boilerplate that's already there because someone else already wrote it. And what we try to address over here is all of that overhead that is just really copy and paste and just essentially like switch a few values. That type of stuff should be auto-generated so that people can just be productive in doing what they do.
How do you handle authorization? Is there partial authorization of the CPI?
Okay, yeah. So let me go back over here. So the proxy layer here is the one that enforces authorization. We actually have one of the other services that we have around here is an authorization and user service, and that one has the user tokens and whatnot. So what happens is when a request comes in with a request would come in with an authorization header, hits proxy. The proxy layer talks to this other service, and whether or not like is this a person or is this is this request with this API key allowed to talk to the service that it's trying to go to. If the answer is yes, it will forward the request in our internal infrastructure to that service. If the answer is no, it will return a 401.
And is the proxy homegrown?
Yes, the proxy was homegrown. I think that was one of the bigger like question marks early on in the process about like, are we going to regret building this? And I think the answer right now is no, because we're able to do things like add rules in there to actually validate the schemas, do things like upcasting and some of our older partners, mostly like shipping carriers and logistics companies, want things in in ugly envelopes, or they want things converted into something else, and we can easily do that there without polluting any of the individual services. Okay. When we had our first clients, I'd say a lot of this bottom half over time, like we really consolidated on asynchronous event streams over, say, the past year. But our first clients, when they appeared here, a lot of this layer wasn't built out yet, and a lot of these services were talking to each other via REST calls. But the interaction from that from the top half of the slides through the proxy layer through these microservices were there when our first clients came online. Cool. Okay, thank you.